Taking our understanding of conditional statements a little further, we have this rather long set of code, and it all comes together to make one little program. We're going to go ahead and just take this part out, and let's dissect what we're doing here. So let's pretend that this is, or not pretend, but rather finish up this program, which is a word guessing game where the person who wrote the program has a secret word and is asking the user to, or telling the user to guess what it is. Now you and I can see that the secret word, which is right here is word 2, is the word kayak. But let's go ahead and run our program, and you'll see that this center window here, this is what the user will see. The words, I have a secret word, guess what it is, and they won't know. Now when they go to try and guess a secret word, what we'll see happen, let's go and try something here. We're going to try guessing the word kazoo, alright? Kazoo, like the instrument. I input that, and it'll tell me that I got the first letter correct, which is the case. The K of kazoo and K of kayak are the same. But there are two other conditions here, so let's see how those work. One of them says if the first character of the word inputted by the user is greater than the first character of the secret word, then we tell them that the secret word, and I'll add the word secret in here just so it's very clear which word we're talking about, say that the secret word is earlier in the alphabet, versus if it's less than it, it's later. Okay, well let's see how that runs then. Because let's just see if that works. You know, the idea is that if the word is kayak and I guess ant, it should tell me that my secret word is later in the alphabet, right? Because the K comes after the A. The way we might think of that is word 2 is the secret word over here, and then word 1 is the word ant. The A of ant is less than the K of kayak. We can compare, as you see here, characters like how we do numbers. In much the same way that, for instance, if we had an A and a C, in the same way that you could compare 1 and 3 and say 3 is greater than 1, you could also say, comparing A and C, that C is greater than A. We do kind of just convert these into numbers when we use them like this, and it works just fine. And let's go ahead and test it out now with a word that should say it's earlier in the alphabet. So if I were to jump all the way ahead to the word water, it'll tell me that the word kayak is earlier in the alphabet. And we know that just based on these things right here. So far, hopefully you get that this control structure that we have entered here is going to check the first characters of the words, and depending on what they are, it'll tell them that the secret word that they're trying to guess is either earlier in the alphabet or later in the alphabet. If it's neither of those things, then it must be the same thing. If it's not less than or greater than, it must be equal to, in which case we get the first letter correct. That's when we typed in kazoo, and it said the K was correct. So right there our user would know, and later when we get to what are called loop structures, we'll see this repeated. The user will get to know that they got the first letter correct, and then they can keep guessing letters. Let's go ahead and add in a little bit of functionality there, though. So far we just have the 3 of these, which are complicated enough on their own. But we're going to use something called a nested if statement structure. And the way that works is, you notice how I have this tabbed ahead of the else, because it has to be? Well, if I keep the tab and then go if word 1 at 1 is greater than word 2 at 1, then right here, this would only have, this is a print statement that would only happen if both this and this were correct. When we nest an if statement, we make it so that way it will only happen in the event that the part of the if statement that's inside would also happen. Let's go and see that run a little bit. So we'll compare the next words. So if they've gotten the first letter correct and then the second letter is their second letter is later in the alphabet, we want to let them know that the word is still earlier in the alphabet. Because it's true that they got the first letter correct, but it's also true that it isn't quite the correct word, and that word is still earlier in the alphabet. And I can really just add in that whole structure here with the L, if, and else. I'll go and put it all in there. I'm going to go ahead and tab each of these forward. And I'll change this to character 1. And then I'll tell them if not they got the second letter correct. So watch how this works. We can use our word kazoo again. And this time it'll tell us that we got both the first letter correct. Then it'll enter this if statement structure. It'll notice that the character of the user's word is not greater. It is not lesser. It is the same. So it's going to run this part here. The second letter is correct. If we had this and we said K and then this isn't really a word, but let's say I just misspelled kazoo. KZ, and then inputted that, it'll tell me I got the first letter correct because the K is still correct, but then it will tell me, okay, but the Z is later in the alphabet. So right there, it's telling me that, okay, the word kayak is earlier in the alphabet than the word kazao. And as long as you get that, hopefully you can understand when I copy this section. Paste it here, and tab each piece forward to make it another one of our nested ifs. I'm going to check with the third character this time. And this allows me that if they were to try and let's do this. Let's see where I guess what it is. Let's try kazoo again. You'll notice I got the first two letters correct, but I did not get the third letter correct. It just tells me that that's earlier in the alphabet because the Y comes before the Z. And so that's what we see right here, because the Z of the user's word is greater than the Y of the secret word. We could even go a little further and maybe just try guessing kayak, and notice we get all three correct. And then we could even go further to get to the fourth one. Just keep it going. Now, this is going to be the last one I do for this part, just because there is something else I want to show you, and there will be a better way of doing this later on. But right now, I really want you to understand how these nested if statements work. Now notice, if I were to run the module, and I were to pick the word water again, and I hit input it, you'll notice it'll just do this first part right up here. Because it doesn't matter if any of the other things are true, because we never got to this part. If we do this, we don't do any of the rest of this code, because it's not inside the if statement. Now, if we had gone outside of the if statements, and just printed out something out here, or put another if statement out there, then yes, it would go ahead and show up no matter what, right? It doesn't have to be. But, since it's not, this stuff, there's only going to the question of whether or not to display if the fourth letter is correct will only show up if we get to this else. If we stop at either of these two because they were correct, then we don't do any of the rest of that, and all we see is that one sentence. But if we go on, we can go ahead and see how we get each of these letters correct, or if we were to try it like that, you'll notice that it'll show the first two letters are correct, but then letter 4 is wrong. We can continue controlling this. This control structure allows for our program to branch out in different ways. It can also result in a very quick ending, just right at the first part. It can also stop us a little earlier. Watch me now stop this not at the 4th letter, but at the 3rd. And when I do that, it will stop at the 3rd, because for that 3rd letter, I'm going to switch back to the code real quick. For that 3rd letter, right here, this is where it's giving me the first 2 letters, right? You can see the print statement for you got the 2nd letter correct up here, which is inside that else. So we hit that else, and then we went down here, and then but since we hit this if statement right here, this first if statement, we ignore this else, and therefore everything inside of it. So the only thing we're going to do is this part on the left side that says that the secret word is earlier in the alphabet, skipping that 4th letter check down here. Because again, if we don't go to that else statement that's holding the nested structure, then we won't go into that structure. When you nest, you make it so that way it will only happen if they enter that part. Which is, of course, very similar to those Choose Your Own Path books from back in the day, because that's really what it is. You could start up the runtime, and it will immediately end, just because you made entirely the wrong choice. It could be you go on for quite a while, and then almost make it to the end, but make the wrong choice somewhere along the road. It could also be you make it all the way to the end. These are all options. This control structure of the conditional statements makes it so that way your program has all these branching paths in it. So we have our program here, and it wants us to guess a secret word. Well, there is, of course, an issue. If I were to type in K-A-Y-A-K, kayak, which is our secret word, right? And then I input that, it's going to tell me that I got the wrong answer. Which is odd, right? It says that my secret word is later in the alphabet, and yet it's the exact same word. Taking us back to the ASCII table again, you might remember that it's really not the same. You see, in the program, I'm going to go ahead and type this out right here. In the program, kayak is not equal to kayak. And the reason is because they have different ASCII values. And here, let's just go and type that in. They have different ASCII values. Cut back through there and have it like cut to this. And the reason is they have different ASCII values. They have different ASCII values. Because when you're looking at it, this lowercase k and this uppercase k are actually different letters. They're different codes. So here's what we do to fix that. We have to make sure both words are the same case, upper or lower. Now, if you notice, our word is already lowercase, and this is kind of intentional, because the easiest way to do this is just to make them both lowercase or uppercase. But word 2 is already lowercase. So let's go ahead and do that. So what I do is to take word 1, which has just been inputted by the user, and I set it equal to word1 dot lower. So right there, this function will change word1 into a lowercase word, though it doesn't actually alter the value of word1. It more or less just returns it. We'll see that in a bit. But yeah, so that's going to make the lowercase version of the word, and then we just save it into word1 in the end. And I'll show you this because here, I'll show you it both with and without the equal sign. Just make sure you always have that equal sign. So first one is I'll have it where it says it's still not lowercase, and then we'll have one where it says is now lowercase. So you'll see the difference here. You do need this equals. But when you have this equals, however many capitalized letters they give, it will go ahead and make it lowercase, as long as you do this whole thing. Word1 equals word1 dot lower, or whatever the string is. I'm going to remove these other things. I'm also going to comment out the print statement. Commenting out turns it into a comment, and now that it is a comment, the computer will not run it. So that way, when the user types in their word, whatever they type in, it's just going to make it lowercase, and then it will check it. So that helps beat that part that we saw earlier, where if we gave it a capital letter, it would mess things up. But if we make them all lowercase, then we go ahead and take care of that immediately. This is, of course, preferred to just asking the user to put in a lowercase word. Because here's the thing. You want to reduce the chance that your user breaks the program. You want your program to look as good as possible, so it's got plenty of foolproofing. So you want to go ahead and take care of that lowercase part right there. Plus, it also looks good on you if your program is more flexible, able to handle minor mistakes on the user's part, isn't so finicky about things like capitals and lowercase letters. So that's just something you need to know, is that you need to know this dot lower function. So putting that all together, the various logical operators in the conditional statements, the nested conditional statements, the dot lower keyword added on here, all of this, and the input from before, and everything else we've done before, all of it really just comes together, and we can really start to see what we can do with this. Hopefully some ideas are starting to materialize, things they're able to do with the ability to make decisions, both with numbers and with strings. We'll keep building towards that eventual goal of building that word scrambling game, which will, of course, use these character little slices and certain other slices. It'll use the dot lower function. It'll use various print statements, various if statements. We're really going to try and build something good with that. So let's keep gearing ourselves towards that. Just make sure you have those conditional statements down in addition to everything that's come so far. Remember, programming is something that keeps adding on to itself. Alright, well, I guess that's about it. Please email me or ask me in class if you have any questions, and good luck with the assignment. Alright, have a good one.